Hello students, welcome to the class of science. Today we are going to start our next topic in the continuity of the previous lectures. Today's topic is extraction of metals of high reactivity. In the previous lectures we have discussed the the extraction of metals with low reactivity and moderate reactivity. Now we will again repeat the reactivity series. Here are the metals in the reactivity series from top to bottom. The top elements are very much reactive. They are most reactive metals, right? And below at the bottom they are least reactive metals, and few are moderate reactive metals. Now in case of the highly reactive metals, it is not possible to reduce the oxides of these metals with carbon or carbon monoxide or metals of high reactivity as we did earlier, because the oxides of most reactive metals like sodium, it is sodium oxide, right? They have more affinity towards the oxygen. They have more strong bonds with the oxygen. So it is not possible to heat them or with the carbon, because carbon cannot reduce these metal oxides, and by this method we cannot extract the pure metal. So what we will do? We will pass electricity from these oxides or these compounds of highly reactive metals. When we pass electricity, it is known as electrolysis. It is known as electrolysis. We can break this word. Electro means bypassing electricity. It is by passing electricity, and lysis means to break down. So by the process of electrolysis, we can extract the pure metal from its oxides or other compounds. Now when we extract the metals of high reactivity by passing electricity, this is known as electrolytic reduction, which is known as electrolytic reduction, right? Electrolytic reduction. Why? We can now take the example of one compound, that is sodium chloride. That is sodium chloride. Its formula is NaCl. It behaves like Na2 because sodium has the tendency to lose electron and oxygen has the tendency to gain electron. Same is in the case of sodium chloride. Sodium has the tendency to lose electron and chloride has the tendency to gain electron. So we will take the example of sodium chloride. Now let's see how we will do electrolytic induction. We will take a big beaker, right, like this. Now in this we will put molten sodium chloride. What we will put? Molten sodium chloride. Now students, you can ask why we have not taken the aqueous solution of sodium chloride. Because if we will take aqueous solution in water, so the oxidation and reduction will be taken place by hydrogen and hydroxide ion. So we will not able to get the pure metal. I will also explain to you afterwards. But now I tell you, we will take molten sodium chloride, and here we will take two electrodes, right? These electrodes will be inert electrodes. Inert electrodes means they are not reactive themselves, right? They are not reactive themselves. When there is a molten sodium chloride, then there will be many sodium ions like this, positive, many sodium ions and many chloride ions, because it is in the state of molten, like they must be scattered here and there. Now we will connect these electrodes with a battery. Like this. Right, students? Now here is the negative charge and here is the positive charge. When we will connect it with the battery, the electric current will start flowing. Now what will happen? Here I have written negative charges. There are lot of negative charges and there are lot of positive charges. Now when we will pass electricity, when we will join it with the battery, the positive charges will start flowing towards the negative charges, right? Towards the opposite charges. Now sodium particles, sodium ions will start coming over here at the negative charges, right? Because they are positive and they will go to the negative charges. So when this sodium will get here, it is get deposited here, it was positive and it went on to the negative charge. So what will happen? It will get electron. It will become sodium solid. It will become sodium solid, right? Sodium metal. And in case of the chlorine, which is negatively charged, it will go to the positive charge, C. It will go to the positive charge and it will form a chlorine. What it will form? Chlorine. We can also write like this, right? It will become a chlorine gas. It will become a chlorine gas and here we will get a sodium metal, right? When sodium is getting one electron and it has become sodium solid, it is getting one electron. So what we call it as reduction. What we call it as reduction, and this is known as, where the reduction is taking place, this is known as cathode. What is we call it as? Cathode. And in the chlorine, what is going on? It is oxidation. It is oxidation. So this is known as anode. This is known as anode. So the metal is getting deposited at the cathode. So students, if we have got water over here, if we have got suppose water over here, there must be positive and negative these ions, and these will get, hydrogen will get over here and hydroxide will get over here. So it will be very difficult for us to extract the metal, because hydrogen and hydroxide ion will immediately take place of the sodium and chloride. So we always take the molten sodium chloride. So this is all the electrolytic reduction by which the metals of higher reactivity can take place. So students, that's all for the today. What we discussed? We discussed the extraction of metals of high reactivity which can be extracted by the electrolytic reduction. We took the example of molten sodium chloride and we saw the process of electrolytic reduction. Students, that's all for the today. Hope you must like my lecture. So if you like my lecture, then please like my channel, share and subscribe. If you want to improve, if you want some improvement in the lecture, even then message me. I will be very thankful to you. Thank you students. Have a good day. Stay home. Stay safe.